There's our question. X plus y less than or equal to -5, and they want me to graph it. X plus y less than or equal to -5, and they want me to graph it, to get a picture of it. So, what's different here? How's this different? Haven't we been doing graphs? Why are we having a whole new section here? What's changed? Isn't this just the same old stuff? What's different? Yeah, instead what do we normally have there?
Equals.
Yeah, normally up to now it's always been equals. Everybody dial in with me. That's what's different. Less than or equal to, not equals. Right? So what does that do to the graph? Well, I think it'll actually be really simple. Once we get y alone. So let's start by doing what we normally do for graphing, which is get y alone. Right? We get y alone. So let's go ahead and do that. Go ahead and get y alone. And so what is it going to take to get y alone? I got to take this x and jump him on over to the other side, huh? What happens when x jumps to the other side? Becomes a negative x. There we go. Y's alone. That wasn't hard. Okay, so now if I'm going to graph that, and I am going to graph that. I'm going to graph that thing. Where do I start graphing? Where's my first dot? Yeah, can you put the first dot on the graph? So this is 90% of this will be just like what we already learned with a little extra wrinkle at the end. So go ahead and put the first dot on the graph. When you say -5, is that left 5, right 5, down 5, up 5? Where is that? Down 5. We all good? Because that first dot, the starting dot, is down in the middle. Down the middle. 1, 2, 3, 4, 5. Good, so there's our first dot. Remember how we do that? Whatever number's off to the right, that's our first dot. All right, now where do we go from there to get our second dot? Yeah, where do we go? Yeah, it's the slope in front, huh? And what's in front here? 1 over 1. Remember, if there's nothing in front, it's 1 over 1. Remember that? And the negative goes on the top only. Keeping all these facts together. Keeping it all really, really well. So that's rise over run, isn't it? So that means we go what? Down 1, over 1. For this, down 1, over 1. For the second dot. We good so far? This makes sense? So the first dot is at down 5. The second dot is down 1, over 1. Rise over run. Down 1, over 1. And now what do we do with those dots? We just connect them, right? So I'm going to connect the dots here with our line. All right, all of that you already know. I really haven't done anything new. All of that's review. Now comes the new part. If it said y equals, then that would be just a straight line. We'd be done, right? If it said equals, But it doesn't say equals, it says less. It says y less. So where do you think we're going to shade? Basically, we're going to shade. Where do you think we're going to shade? Above the line or below the line? Yeah, what do you think less is going to mean? Below, huh? Yeah, but there's something else. You know, when we're graphing, what we're really doing is we're saying all the points that are true light up. It's like a big light bright. Remember that toy? Light bright? Remember that old toy? Yeah. I always wanted that toy. I never got that toy. But right, you put it in the pixels and they light up. Well, that's what a graph is like. It's basically all the dots that make the thing true light up, or they're on our graph, you know? That's what you're doing when you're graphing. You're showing all the points that make it true. That's always what you're doing when you're graphing. You're graphing the truth, the points that make it true. So what am I talking about? Well, all the points that are right on the line, did you know they are all the ones that make it equal? Right? If this said equal, I would only have points on the line and nothing else. Because only points on the line make it equal. What am I talking about? Like here, let me just fool with you. You don't need to write this down, not required, but I want it. The more I can get the real idea in your mind, the better you'll know what to do just naturally. What are the coordinates of this point right here, this big dot right here? He's over how far, up or down how far? What are his two numbers, his coordinates? Over 0, down 5. Right, you tracking with me? That point is over 0, down 5. That's his x, comma, his y. What I'm claiming to you is if I put in his x and put in his y, he would make the statement equal. You see it's true, don't you? Come back up here. Put in the x is 0, the y as minus 5, right? X is 0, y is minus 5. What do you get? Minus 5 equals minus 1 times 0, that's just 0, minus 5. Minus 5 equals minus 5. See, it's equal. What about this point right here? We said that's another point that's on the graph. Can you tell where that point is? It's one more over, one more down, huh? So what's his coordinates? From the origin, it's over 1, down 6. Everybody see that? Guess what would happen if I put 1, negative 6 into the original equation? It's going to make it equal, huh? If you put in 1 here and negative 6 here, you're going to get negative 6 is negative 1 times negative 1 minus 5. Negative 6, wait a minute, that didn't work. Oh, not positive 1 because I messed it up. Minus 1 minus 5, negative 6 equals 8. You probably can't even read that, I'm writing small. It's true. So I'm showing you that all the points right along this line make this statement true. They are the truth. For the equals, now I changed it. It wasn't originally equals, was it? What was it originally? It was less than or equal, right? So in other words, what they're saying to me is they're saying, hey, I want all the points to light up, light bright thing. I want all the points to light up that either make the equation less or equal. Right? That's what this says. Well, we know the ones that make it equal. It's all the brrr, right along that line, right? All of those make it equal, don't they? So where are the points that make it less? They're all the zillions of points. Zillion's not really a number. But you know what we mean. The infinite number of points that are all below. Pick any point you want that's down below there. Like, how about this dot right here? That's below the line, like over 0, down like 8 or whatever. If I put in x is 0, y is 8, if you put in y negative 8, x 0, see how it comes out less? Negative 8 is less than negative 5? That would be true for any point you plug into that thing that's below. All these millions of dots out here, if you put in their two numbers, right? Every dot has two numbers, right? How far over, how far up or down. If you put in all their two numbers to this thing, they'd all come out less. And guess what would happen if you took any of the dots up here, the millions of dots up here, and you put in their two numbers? What would you get? Greater, because it's above. This is greater territory. All this is all greater. When you're above the line, you're making stuff greater. Down here, this is all less territory. And right on the line, that's equal territory. And now I've made a big mess out of my graph. But you get the idea, right? Everything above the line, all those dots make the thing greater. Below is less. Right on the line makes it equal. Okay, well then, what do they want? Let me clean up the mess I made here. Let me go to a fresh one. There's no cleaning that mess up. So x plus y less than or equal to minus 5. We'll go much faster on the other ones. I'm just giving you the big story here. And I got y alone. Right, I jumped the x over. Negative x minus 5. Okay, and then we graphed it. We started it down 5. And we went down 1 over 1. We got that line. Okay, so there we are. We're back where we were. So there's line. Now, What are they saying they want from us? They're saying, what does this say right here? This says, give me everything less than or equal to, please. Will everybody line up who's less than or equal to? So what's going to light up? Everything below the line. All the millions of points. This line goes up forever. All the millions of points below and everything on the line, huh? Because those are the equal ones. They want the lesser and the equals. The below the line and the right on line. That's our answer. It's the line and everything shaded below. And on Math Excel, they give you a little, my math, they give you a little paint bucket. Have you seen it? You done it? Let's go paint. We good to there? Really easy for you. You've arrived. You've made it through the hard stuff. Okay, there you go. Graph that one if we're good. So we have to get the y alone. We always start graphing with the y alone, right? Carlos was asking a good question, and that is, hey, when do you have to divide? Can you always just jump things? This new little shortcut thing I'm giving you guys. Can you always do that, or when do you have to divide? Yeah, if it's like right next to y, then you divide, meaning no symbol in the middle. See how this has a symbol in the middle? So it's not right up against it, right? For example, let me go back. Let me show one. Oh, I can't. It was the earlier homework. Well, I could write one. If you had like 7y greater, you'd have to divide that 7 off on both sides, right? You see that? Because that 7 is right. It's timesing the y. So if it's timesing, you got to divide, because that's the opposite of times. But anything else, anything added or subtracted, just jump it, and it switches signs. So we get y greater than 3x minus 3. Good there? Because that minus 3x jumps over, becomes a positive 3x, huh? Good? We're ready to graph? To the graph we go. Okay, so where's our first dot?
3 down.
Yeah. We start. Down 3. 1, 2, 3, right there. Okay, and then where do we go from there to get our second dot?
Rise to the region.
Yeah, you put 3 over 1. That's rise over run. So from here you go up 1, 2, 3 over 1.
Yes.
You do count the axis. That is the third jump. So right, so we're going up 1, 2, 3 over 1. 3 over 1. Rise over run. Connect the dots. Now, when I connect, well, let me just do it first, and then I'll go back and fix it. So you connect the dots. Now, we've got the line. Now it's time to decide about the shading. Where do they want us to shade this thing? What does it say? Y is greater. Where's the greater stuff?
To the right.
Above. Well, above. Yeah, don't think right left. Yeah, good. I'm glad you brought that up, Manuel. But don't do that. I'm just kidding. Yeah, over the years, you reminded me what I've seen over the years. People get tripped up if they start thinking right, left. Don't think right, left, why? Because it's y alone. Y is not, if the y-axis is about above or below. Think about the y-axis right here. Right? See, if we got x alone, we'd think right, left, because x is right, left. But we have y alone. So always think about the y-axis. It says, give me the part of the y-axis that's greater. That's up here, huh? Does that make sense? So yeah, don't accidentally think right, left. That'll get you, because we have y alone. So it's this side. We good? Because that's the y greater part there. Now, one other small wrinkle, probably some of you know. Yeah, the line's a problem here, right? Because remember, we're doing the like right thing. We're saying, hey, I want everybody to line up that is greater, and that's it. Just not equals. There's no equals bar there, is there?
So it's no line.
So there's no line. Remember, because all the dots, the millions of dots on the line, they make it equal, don't they?
Yeah.
And they're saying, we don't want that line. We don't want that line. We just want, that line does not get to light up. Only the things greater. Only the stuff above the line, not the stuff right on the line. Because the stuff right on the line is equal, right?
Yeah.
Above, greater, equal, less. Huh?
Good.
Well, how do you do that? Just think with me practically here. How could math have done this? They're saying somehow we have to draw a picture. Let me do it over here. We've got this line. We're supposed to shade above the line because it says greater. but not the line itself. Well, so you got to erase the line, right? What could they have done? And then just shade up really close to the line. That would have been a dumb way to do it, huh? So what, do you see how that would have been a problematic? Because that's the idea. That is true. We're shading above it, but not the line itself. But do you know, yeah, and probably a lot of you know, what they do instead to say that the line's there, but it's not there? They dotted the line. So you go back and you make your line dotted. Dotted line means it's not really there. In other words, it's just there to serve as a border. But it's kind of like if you don't have a fence between you and your neighbors. There's still a property line. Still a property line. Other states, they don't have so many fences. We're into fences in California. I lived in Kentucky for about 5 months. And it's pretty much more wide open there. Not as many fences and all that. But there's still property lines. It's kind of what this dotted line is. It's a border, but it's not really there. That's what it's doing. It's saying, I'm not really part of the answer, but I'm there as border. On the Math Excel, my Math Lab, I won't go there again, and it'll take me forever. You guys will all laugh at me. But there's a dotted line option. There's a little place where you can make your line dotted instead of solid. So it's silly for me to try to teach you about technology. You're all 10 times better than me. So I'm sure you'll figure that out with the greatest of ease. Questions on this then? That makes sense? And they want us to graph it. With me? 3 over 1 x plus 0. Right? We always have to get our equation into that form where we see those three numbers without really changing any values, huh? Yeah. Then we can graph. We good? So now you know how to get your two dots, right? Get your starting dot, get your second dot, connect those two dots, and then decide about the shading and whether it's a solid line or a dotted line, that whole thing. So where's our first dot? Yeah, start at 0. Right there. Okay, good. And now, how do we get to our next dot? Yeah, rise over run, huh? Rise over run. So we go up 1, 2, 3. Oh, and go up 1, 2, 3 over 1. We good there? So then connect the two dots. All right, and where's now should it be a solid line or a dotted line? Yeah, so basically, yeah, you guys are right on the money because you want the equals, huh? Basically, here's a memory device that I usually say to help students. If you have a solid bar there, you're going to have a solid line. If you have no solid bar, then you have no solid line. It should be dotted. You know what I mean? But it's better. You guys know why, and that's even better. I can tell you know why. It's because equals is on the line, huh? And they want the greater or equal, so they want the line. And they want the greater. Now, which side's the greater? Don't tell me right or left. Remember, we don't think right or left. When y is alone, we're looking at the y-axis. Right? We're just looking at the y-axis. Which part of the y-axis do we want? The greater y-axis. Where's the greater y-axis? Up here. Above. Huh? Like that. Is that good? There we go. That's good? Questions on that? All right. All right, try that one. See if you can graph that one. What's the first thing you always need to do on graphs? Get y alone. Y must be alone. So get y alone on that one. Things. When can you jump things? Why can't I just grab this guy and jump him over and make it x plus 9, and that's just wonderful. That's not true right there. What's that? Yeah, if it's right next to the y, I can't. Right. Does that make sense? Because that's 9 times y. The jumping is for added, subtracted things, right? That's why I say it just changes signs, because you just adding becomes subtracting, subtracting becomes adding, right? You know, that's all we're doing with that jump trick. But yeah, I know if the number's right next to the y, if it's multiplied by the way, you've got to divide. You can't jump. The jump's for added, subtracted pieces. We can't do that. So what was the question? X less than negative y. X less than negative 9y. All right, so instead, no more trying this one on your own. Stop that. No more. I'm just joking with you. But really, I do need to show you something that you may or may not already know. So what do we need to do first off? This you do know. What do we do? Divide. And when I divide, do I divide by negative 9 or positive 9?
Negative.
Yeah, always exactly. Whenever you divide, it's identical twin, right? And whatever you do to one side, do the other. Okay. Do you know the trick that when you divide by negative, you got to flip the symbol? I knew some of you would know. Yeah, it's a little trick. You have to actually turn the symbol the other way when you divide by negative. Let me write a note here for you. It's when you multiply or divide. So when you divide by a negative, you must flip the symbol. I forgot about that. So yeah, you got to see how I turned the symbol the other way? So you got to do that. So we get x over minus 9. And this is why these minus 9s cancel. So it's like that now, huh? Now we're ready to graph. To graph that, you got to have the 3 numbers. So put in the 3 numbers and graph away. Totally do exactly what you guys are saying. I would take this minus, move it up here, make it minus 1x over 9 plus 0. That would be the easiest way to go. Get all 3 numbers out invisible. Right? I haven't changed anything, have I? That's totally legal to do. Right? A minus on a fraction, doesn't matter top or bottom. And there's nothing to the right, so make it 0. Now can you graph? So graph from there. Okay, so let's graph this thing. So, okay. So where do we start? Start at 0, right smack in the middle. There it is. And then where do we go from there? This is rise over run. So if you rise negative 1, that is down 1. And then run, go over 9, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 1 over 9. Connect the dots. It's going to be a pretty flat line, isn't it? Oh, yeah. Yeah, right. No solid bar. No solid line. It's got to be dotted. All right, so I got to go back and I got to dot that line. You're right. So I'll just kind of do it sort of like this. All right, so there we go. Dotted line. That's right, because we're not doing the equals part, are we? We're only doing, this, not the equals. They don't want the equals. They don't want the line. Now, which side of the line do we shade? Now, I was looking around at your guys' work, and it looks like pretty much everybody I saw was doing it right. But I want to make sure you do it right even on the test. So somebody could look at this, and I didn't see anybody doing it, and go, oh, that just is greater, so I can do greater. But no, that's not right, is it? What you guys are doing was right. You got to start with the y. It's all about y. Because remember, we're honed in on the y-axis. So y is on which side of the symbol? Smaller. So it's smaller y values, huh? Not greater. It's from y's perspective. Right? Yeah. So the shading's down here. Because y is less. See, y is on the lesser side of the symbol. It's all about y. There we go. Shade below dotted line. Is this good? Questions? I want you to graph that one. See what you can do.
Is it just on the Y? Isn't it just on the
Yeah,
Y?
it's a MB plus.
But you added an X and it doesn't exist on the front.
Right, that's the problem. You can't put in an X that wasn't there.
Oh, okay.
Changed it.
Oh, wow. Let's see what happens then.
All right, so would it be right to say that 4, put it over 1, that's my slope, up 4 over 1? No. Why not? Because that 4 is not next to X. There's no X here at all, right? So you can't, he's not a slope. What do you do when there's only one letter? Only one letter. We've only got Y here. We don't have X anywhere. What do you do when there's only one letter? What do you do?
It's undefined?
No. That's that's when the bottom zero's underneath. Yeah, you just literally go to the graph, and remember, this is the x-axis, this is the y-axis, and you just shoot a line right through y is 4. 1, 2, 3, 4, right there. And the line, now is it a solid line or dotted? Yeah, because there's no solid bar here, right? So no solid bar, no solid line, dotted. Yeah, you just shoot it right through 4. So when there's only one letter there, the line is always straight. Now really that's a dumb thing to say. All the lines are straight. But you know what I mean. It's like straight sideways or straight vertically, huh? Right? When you only have one letter, yeah, so maybe that's worth writing. When only one letter, when there's only one letter, it's either a straight sideways line or a straight up and down line, isn't it? It's that or that. It's one of those two. When there's just X or there's just Y, it's always going to be most of the battle right there. Is you go, okay, look, it's just Y4, it's just right through the 4. Now, we do have to do the shade. We know it's dotted line because there's no equals bar. No solid bar, no solid line, dotted. Now, do I shade above? Because greater than less than always has shading one side or the other. Do I shade above or below? What do they want? Y is
Below.
less. Lesser Y values. Shade everything below. Huh? Done. That make sense? See why it's not a slope? There's no X there. If that was 4X, then we go, oh yeah, that's a slope, 4 over 1, here we go. You know? That'd be totally different, wouldn't it? The presence of that X would change everything, wouldn't it? That would suddenly be a slope, 4 over 1. I'd put a 0 out there. I'd start my dot at 0, go up 4 over 1. I'd have a slanted line. Everything would be different if the X was there. But because the X is not there, when you have only one letter, it's always a straight line, meaning straight sideways or straight up and down. When you have only one letter, the line has no slant. It's not diagonal, it's straight, up and down or sideways. All right. Can you graph that one? Is this line going to have slant to it? No, it's going to be straight up and down or straight sideways because it's only got one letter, huh? So just shoot a line through the x-axis at -8. And then figure out which side to shade. Okay, so what it's going to go through which axis? The axis is the x-axis, this is the y. So -8, 1, 2, 3, 4, 5, 6, 7, 8. So there it is. At -8. We good so far? Got a line going through the x-axis at -8. Now, should it be a solid line or a dotted? Solid, because we have a solid bar, huh? Solid bar, solid line right here, solid bar. Okay, now, this is the one and the only time where we do indeed need to think right or left. Remember how I said don't think right and left? Well, actually, now we need to. Why? Because we have x alone, not y. There's not even a y here. So we're not thinking y. We're not thinking above and below. We're thinking right or left because we have x alone, huh? So which side should we shade? Should we shade the right or the left? What does it say? X is greater. Where are the greater numbers on the x-axis? To the right. Positive numbers go to the right. So we'll shade everywhere to the right. like that. There's our answer. Is this good? All right. Okay. Try that one. Graph it. So what do you got to do first on this one? Got to get y alone, right? So get y alone. Okay, so we want to get y by itself. That's always the goal. What do I do first to get y by itself? Grab this 2x and jump it over, huh? See, that 2x, I can just jump the whole thing because it's added, subtracted piece, right? Remember, added, subtracted things, we can just jump them over. So that will give me 3y less than or equal to minus 2x plus 6. Good so far? Now, y's not quite alone yet. One more step. What do we do now? Can I just jump the 3? The 3 must be divided. When you divide all of them. Remember, whenever we divide, it's all 3? Like that. Remember that? See the difference? See how the 3 is multiplied by the y, huh? So you get rid of it by dividing. And when you divide all 3. Remember all those details of those small differences? Good there. So then, what do we got? Y less than or equal to minus 2/3 x plus 2, huh? Now we can graph. So now go to the graph. Now go to the graph. See what you can get on the graph now. So I'm going to go to a fresh screen to graph it. What's that? Oh, good question. Yeah, what about the sign changing when we divide? Should we flip the symbol? No. What did we put under the bar? A positive 3. Good question, Corinne. It's only if it's negative. Really good question. Yeah, right? We all good on that? Only if you put a negative number under the bar, only if you divide by a negative, do you need to flip the symbol the other way. It's true. We hardly ever do that, though, so I don't want to bug you with a lot of things you aren't going to need. But you're right, Carlos. That's true. That is true. So graph it from there. So, all right. Where do we start our graph? 2. Yeah, start right here. And that's always on the middle line, huh? Right? Start it up 2. So 1, 2 right there. 1, 2. And then where do we go from there? This is rise over run. So I go down 1, 2, over 1, 2, 3. Right there. So down 2, over 3. See how we got that second dot? So we started it up 2. We go down 2, over 3. So we've got our 2 dots. And then we connect our 2 dots to form a line. Is it a solid line or dotted? Yeah. Solid bar, solid line. And which side are we going to shade? Yeah, because it says y less. Lesser things are on the bottom, right? The lesser y-axis. The y-axis going down. Shade the bottom. Is that good? Then the hard part of the work was getting the y alone, huh? Are we good with those steps? Back over here where I got y alone. So I jump over the 2x and I divide by the 3. on that. Good. All right, let's go ahead and graph that one. So yeah, to get y alone, I'm going to show you two ways. So one way is just grab that x and just jump it, right? Because it's added or subtracted. It's, it's not multiplied, so you can jump it. So then you get minus y less than. What happens when that x jumps to the other side? Negative x. And this 1 is really a positive 1. There's nothing in front of it, which is positive so far, right? Good so far. Now, y is not yet alone, is it? What number's next to y?
1.
Negative 1, huh? Negative 1. So whatever number is right next to y, we always divide all three by that number, don't we? That's always what we do. When there's a number right next to y, we divide all three by that number. Now, what happens when you divide by a negative?
Y become positive.
The symbol flips, right? See right here? Divide by negative. Flip the symbol. Just have to flip that symbol. So we get y now greater than or equal to. What is negative? Two negatives here, negative over negative?
Plus.
Positive. So it's going to be positive x over 1. And positive over negative? Negative. There's a 1 up here. We need three numbers, huh? We always need our three numbers to do our graphing thing. Right? 1, 2, 3 numbers. Got our three numbers for graphing. So now we can graph. So let's do it. So we go to the graph. Where's our first dot?
Down.
Yeah, you start down 1. And then where do we go from there? It's rise over run. So you go up 1, over 1. There's our second dot. How we doing? We good? Connect the dots. Solid line? Yeah, solid bar, solid line. Okay, now where's the shading? Is it above or is it below? What does it say? Y greater. Greater stuff's above. There it is. Now, I wanted to show you what you might actually like a little better. A little bit of a quicker way. Where you just jump things around. Let me kind of get rid of some of this. Here's another way. Bring it over here. So it's x minus y less than or equal to 1. Remember what our job is to get y alone, right? You could just say, look, I got to get y alone. I want y to be positive. I'm just going to use Mr. Heron's jump thing. Just grab this negative y. Just jump him to the other side. What will he become when he jumps to the other side? Regular y, positive, regular. And grab this 1 and jump him back. What will he become?
Negative.
Boom. Y is alone. Just jump, jump. Y is alone. No dividing and turning the symbol and all that stuff. Did you track with that? Right? As long as y is alone, it's all good. Doesn't matter which side he's on, whatever. Right? Negative y jumps over, becomes positive y. That gets rid of his negative, right? Because things change signs. And the 1 jumped over, became negative 1. Y is alone. Great. Y greater. Same answer. Same as that. Right? So that's another option. You can just do the double jump. You can always do that. All right, let me rewrite it. 4x minus 3y greater than negative 12. This is number 12. Last one. So graph that one. Get that y alone. Jump that 4x over there. Jump that 4x over, right? Becomes a negative 4x. We good so far? We good to there? So see how I jumped that over? Now, we got to get y alone. How do you get y alone? Divide by -3, right? And I'm dividing by a negative,
Choose the bottom one.
so I've got to flip the symbol, don't I? It's got to go the other way, right? When you divide by negative, flip the symbol. So these cancel. What do we got? Y less than 2 negatives? Positive, 2 negatives? Positive. There's our formula. I know you can do the rest. I'll go dot, dot, dot. The rest is easy for you. I just wanted to make sure you could get to there. Is that good? On getting that alone? Questions I can answer on that?
The shading.
Yeah, so you'll shade
Why
below
is less?
on that one. Yeah, it's dotted line, shade below.